All right, so now we're going to get into proofs. Triangle congruency proofs are going to be the main type of proofs you will see on tests. So we're going to take those 4 triangle congruency statements. Those were SSS, SAS, ASA, and AAS. And we're going to use those in proofs to prove that 2 triangles are congruent. So this first example, first of all, we're going to work our way all the way through these proofs, giving all the statements and all the reasons. Just remember that on any test that you guys will get, you'll have options, and most of the time, either the statement column or the reason column would be filled in, and you fill out the other part. Okay, so let's see. Our given is that AD is congruent to BD. So those are marked with 2 congruency markings right there. And then we have AC is congruent to BC, and that is already marked. Don't forget, our first statement is always our given. So we can write this statement out. We put all of the parts of our given here. Oops. BC. And our reason for that is always given. And what we're going to try to prove is that triangle ADC, so we've got this triangle right here, is congruent to triangle BDC. All right, so let's go ahead and work our way through this proof. So we've already got 2 sides. We've got one right here with AD to BD, and then we have AC to BC. We have another side. So the 2 of them that have 2 sides are SSS or SAS. So let's see, can we get the 3rd side, or can we get an angle that's in between? So I would either be looking for those angles right there, because that's in between, or this 3rd side. Well, that 3rd side is shared, so we can mark that as congruent. So our second reason will be that our statement is going to be that CD is congruent to CD, because we write that as congruent because this CD is the one being used in the first triangle, the blue one, and this one would be the one being used in the yellow triangle. Now, if you have the same thing is congruent to the same thing, that is the reflexive property. Think a mirror. All right, now I have 3 sides. That's what I look at. I like to count what kinds of statements I have. So if I have side, 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 I can now just say that triangle ADC is congruent to triangle BDC by side, side, side. Okay? Some of them will be just as simple as that, 3 statements. Now, here's another one that we will also use side, side, side with, because we would have triangle EFG. So we can draw triangle EFG, and we want that one to be, we're going to determine if that is congruent to MNP. Okay, so we've got all these coordinates for EFG and MNP, and so we can pretend this is on a coordinate plane, but really what we're going to be doing is figuring out the distance of each of these sides, and then if they're, because that would tell us the length of each side, and if all the lengths match up, then we would have side, side, side congruency. So E is at -4, -3, F is at -2, 1, and G is at -2, -3. And then we have M at 4, -3. We have N at 2, 1. And we have P at 2, -3. So I'll start you guys off. Let's find the length of EF first. Okay, so we would start doing the distance, which would be x2 minus x1 squared plus y1 minus y2 squared. And this length we will get about 4.47 with our distance formula. So I'll write that right here on this side. So now EF was the first 2 letters. I want to see if that matches up with the first 2 letters over here, which is MN. So I would do the distance formula for M to N. So I do x2 minus x1 squared plus y2 minus y1 squared. I punched that in the calculator, work out my distance formula, and look at that. Our length of that line, or our distance from M to N, is 4.47. So we've got one side that matches up. Now what I would like you to do is go ahead and find the length of FG and GE and see if they match with NP and PM, because we're going to see if we have a side-side-side congruency. So go ahead and work out those distance formulas. Okay, go ahead and check your answers. So we got that FG right here was 4 and NP was 4, and those sides matched up in our triangle congruency statement up here. So we had those sides congruent, and then we also had that GE matched up with MP. They were both 2, so those sides matched up. So we can go ahead and say that these triangles are congruent by SSS. Alrighty, so if you ever get coordinates, you know you're going for SSS, and you can always use your distance formula to find length. Alright, this next proof. So we have those are segments, DE and BC, and it says that they bisect each other. So let's go ahead and write those statements. DE and BC bisect each other. And our reason is always given to start. Okay, so let's see what that means for our picture. So if DE is right here, and BC is this line right here, and it says they bisect each other. Bisect means to split in half. So what that would do is split it so that at this point right here becomes the middle, and I've got that congruency there, and I would also have that this line, the yellow line, was split up as well. So now I already have some sides that are congruent from the fact that they bisected each other. So let's write that statement. So now I have that DG is congruent to EG. That was one congruency marking I made. And notice how I did it in the same order, D to G and then E to G. But we also got BG is congruent to CG. And we were able to do that based on the definition of bisector. There we go. Okay, so now we don't have any common sides. I have 2 sides, so I'm either going for side, 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 or side, angle, side. Well, I do have vertical angles right here. So, and that would give us side, angle, side. So, if we're going to mark our vertical angles, we will need to use 3 letters to name these angles, because if I just call it G, I don't know if I'm talking about this one, this one, this one, or this one. So this first one right here, I'm going to call that DGB. So angle DGB is congruent to angle, and I'll go back the same order, EGC. And those were vertical angles, so definition of vertical angles. Now we said we have the side angle side congruency statement, so we can say that these triangles DGB is congruent to triangle EGC by side angle side. Okay? And look at in your proofs, if you're ever not sure and they have all of these reasons right here or the statements down and you're not sure which triangle congruency statement there is, well, we've got a side statement, we've got a side statement, and an angle statement. You need to look at what order they are in on your picture, because the order of the proofs is not the triangle congruency statement, but it does narrow it down to tell you how many angles you have and how many sides you have to use in your congruency statement. All right, just 2 more proofs. They all use different kinds of things that you will see. So we had bisectors, and we had our basic side, side, side proof. Now we're going to work with parallel lines. So it says that KM is parallel to JL. So it looks like we already have those parallel arrows here for KM and JL, and we also have that KM is congruent to JL, so I will mark those congruent. So I'll make those my first statement, parallel to side JL, and KM congruent to JL, given to start. Okay, and we're going to prove that these triangles are congruent. Just to be sure, JKM is this triangle here. Always make sure you know what you're working for. Okay, and then MLJ is this triangle right here. Okay, so we have one side that is matched up, okay, and we got to figure out what else we can get. Well, I do see this common side right here, so let's go ahead and put that into our proof. So reason number 2 can be JM is congruent to JM by the reflexive property. Always look for common sides and vertical angles to start, and then you might need to use actually what was given to you. So the sides being congruent, KM to JL, does help us a little bit, but we're probably going to use that KM is parallel to JL. So let's look at what would come of that. So if we have parallel lines, then we have all of our angle pairs. So let's see, if we use these parallel lines, and I'm going to extend them so I can really get a good look at what this picture might look like. I've got those parallel lines. I got to figure out what line I would use as my transversal. Well, let's try to get a gauge at what we're going to do with this proof. I've got two sides already, so I'm either going for side, 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 or side, angle, side. I'm probably going to go for side, angle, side because parallel lines give me angle pairs. So I want this angle to be in between my sides. So I'm going to want these angles to be right here in between the sides. So let's go ahead and use this as our transversal then. Now we look at these angle pairs right here. What kind of angles would those be? They're both inside of my parallel lines, but on alternate sides, so they would be alternate interiors. Okay, so we used alternate interior angles to get that angle LJM is congruent to angle KMJ. Okay, so now here is a side statement, and an angle statement, and we already said we were going for SAS. So our triangles are congruent by SAS. So always know that if you have parallel lines, you will probably use alternate interiors corresponding, alternate exteriors, something like that that will give you a triangle congruency statement. All right, last kind of proof, we have that this segment CP bisects angles BCR and angle BPR. So we can put that as our first statement. And it already put our reason as given. So let's see what that looks like on the picture. CP is right here, and it says that it bisects angle BCR, so that's the whole thing, which would make these two little pieces congruent. And if it also bisects angle BPR, then I would have these two little angles congruent as well. So I already have two angles in my statement. So I'm either going to use angle, angle, side, or angle, side, angle. So I have two choices to choose from. Let's first start filling out our proof. It says that they use the definition of an angle bisector. Well, when I used the definition of an angle bisector, I drew these congruency markings in these ones. So let's just write that as a statement. So I would have that angle BCP is congruent to angle RCP. But I also got the ones down here. So I've got BPC, angle BPC is congruent to angle RPC. So that gave me the little angles. And now I have that CP is congruent to CP. Well, that is our line right here. And that's a common side between our triangles. And if it's same thing is congruent to same thing, we again have the reflexive property. So a lot of these properties you'll see in most proofs. Common sides is always going to be a reflexive property. So now, is my side in between my angles or is it outside of my angles? It is in between them, so I use angle side angle to prove that these triangles BCP is congruent to triangle RCP. All right, so those are your triangle congruency proofs. We'll do a lot more practice with this since these will be the most types of proofs that you see.